Okay, I'm going to take you through how to solve exponential equations using logarithms. So if we go back to this exponential growth problem, we have student, he's going to deposit $1,000 into an account that pays 4% annual interest. And we want to know how long will it take for Stu's money to double. So how long will it take for 1,000 to turn into 2,000? So we set up our formula where the future value is 2,000, the initial value is the 1,000 deposit. We do 1 plus 0.04 to the power of t. So you take 4%, divide by 100, and you get 0.04. We plug all that into the equation, and then the first thing we're going to do is combine 1 plus 0.04 is 1.04, and then we divide both sides by 1,000 to cancel this out, and then that's where 2,000 divided by 1,000 equals 2. So then from this point, how do we solve this problem? 2 equals 1.04 to the power of something. That's a really hard power to try to figure out in your head. And so what we do is we have a log button that stands for logarithm. And so you're going to need a calculator, and you take log of 2 and divide by log of 1.04, and that's going to give you the power. So this is equal to t, and this represents how many years it will take. So roughly about 18 years, somewhere between 17 and 18 years. So you always take, if you have an equation down to this form, let's call this number y, and then the 1.04 let's call b for base, and then if we have t for time, or x could be your variable as well, then to find t, you always end up doing log of y divided by log of b. And the way I remember this is that this b stands for base, and the base always goes in the bottom, just like the bass guitar, or the bass notes are always the lowest. So bass goes in the bottom, Okay, let's try another one. So we'll say it takes about 18 years, and I'll tell you where to round in the problems. Sometimes I'll have you round to the nearest whole number, sometimes to one decimal place, just depends. Okay, next problem. So it's not a word problem, it's just solve for x, but we're going to end up with the same kind of situation. So first we're going to add 3 to both sides. So we get 12 to the power of x equals 30. So then again we're in the same situation where we need to find this power, and it's not a whole number, because once you do 12 to the power of 2, you're already way too high. So we need to use this. Right now we have b to the power of x equals y. So x would equal log of y divided by log of b. So base goes in the bottom. So the base in this case is 12. So we're going to say x equals log of 30 divided by log of 12. So I go to my calculator and type in log of 30 divided by log of 12, and my calculator says this is about 1.3687. And I'm going to go ahead, and it says round 2 decimal places, so that would be 1.37, because we have to look at the 8, and since 8 is greater than 5, that means we round up. So the 6 turns into 7. 6, 7. Okay, next one. Solve for x. There's a few more things we got to do before we can get it into this form. We're trying to get it to be y equals b to the power of x. So we have to follow the order of operations, but backwards. So subtraction and addition would come first. So we need to get this 4 onto the other side by subtracting, because subtraction is the inverse of addition. So then we have 3 times 5 to the power of x minus 1, 22 minus 4 is 18. So then comes multiplication or division. So we divide by 3 on both sides. And you get 5 to the power of x minus 1 equals 6. So now we're in this form. It's just the base is 5 and y is 6. So it's just the other way around. B to the x equals y. And we also have this little minus 1 in here. But at this point, we go right to the logarithms. So we would say x minus 1, or whatever is in this power, will equal log of 6 divided by log of the base, which in this case is 5. So then get out your calculator. Log base 6 divided by log base 5 is equal to about 1.113 and so on. And so if I have x minus 1 is about 1.113, then I'm going to add 1 to both sides. So we get x is about 2.11. And it says round 2 decimal places. So it's already done. 2.11. Okay. One more problem involving exponential decay. So word problem. Mr. Sattler bought a guitar in 2018 for $3,000. The guitar's losing value. So we're going to do 1 minus 0.04 each year. How long will it take? So we're going to try to solve for t again. So we use this formula again. Future value equals initial value, but we do 1 minus r to the power of t because the guitar is losing value. So it's decay. So how long will it be worth half? How long will it take to be worth half? So half of 3,000 would be 1,500. And then we do 1 minus 0.04 to the power of t. So 1 minus 0.04 is 0.96. And then we're going to divide both sides by 3,000. And the left side is going to equal exactly 1 over 2. And that's because we're asking the question, how long will it be? How long will it take to be worth half? Exactly 1/2. So then we're in this situation where y equals b to the power of t. So t equals log of 1/2 over log of 0.96. We put the 96 in the bottom because this is the base, and base goes in the bottom. So then I get out my calculator. Once again, log of 1/2, or 0.5, divided by log 0.96 equals about 16.9797. And so we're going to round to the nearest year, and we'll say this takes about 17 years for the guitar to go down to half its initial value. Okay, thank you for watching. That is it. Happy solving equations. Goodbye. Fibonacci out.